Hi guys, in this video we will solve all the problems in chapter number 1.4 of the course Math 216 Linear Algebra and Differential Equations. Let's read this first question. Find the general solutions, implicit if necessary, explicit if convenient, of the differential equations in problems 1 through 18. In the textbook there are problems from 1 to 18. As per our syllabus we are going to select a few problems to solve. Now let's start with the problem number 8. dy over dx is equal to 2x secant y. Let's solve it by variable separable method. Club all y in one side and other variable x in the other side. So this is going to be dy over secant y. You are dividing secant y on both sides and multiplying dx on both sides. It will be 2x dx. And the left hand side 1 over secant y is cosine y dy, which is 2x dx on the other side. Okay, now integrate on both the sides. This will be sin y. On the right side it is 2x square over 2 plus c, which will give you sin y is equal to x square plus c, where y is equal to sin inverse of x square plus c. You are taking sin inverse on both sides. That's the end of problem number 8. Now let's start 13. And again club all y's in one side and x in the other side. You will get dy y cube over y raised to 4 plus 1 on the left hand side, cosine x dx on the other side. Now when you differentiate the denominator y raised to 4 plus 1, you will end up with 4 times y cube plus 0, which will give you an idea that the integration of this term will lead to ln of the denominator. Or you can try use substitution method, but I can directly use a 4 by 4 here, so that I can use the technique of differentiating the denominator gives numerator technique. The left hand side, when you integrate on both the sides, the left hand side will be ln y raised to 4 plus 1 integration of this part, and there will be 1 over 4. You can try by choosing y u is equal to y raised to 4 plus 1, use substitution method. Okay, and in the right hand side the integration of cosine x is sin x plus c, and we will get ln y raised to 4 plus 1 on the left hand side, which is equal to 4 times sin x and 4 times c. Is another constant, call it big C. Okay, and you can stop here. Otherwise, if you want to take ln, if you want to remove ln, you can take exponential on both sides, but as per the textbook this is the answer. Okay, we can stop here. Okay, now I'm going to question number 16. Question number 16. Again, the variable separable method gives us tan y and this dy, this y prime is dy over dx, and all other x in the other side, x over x square plus 1. Now tan y is sin y over cosine y. You must know direct integration of the tan y, but this is also good. We integrate on both sides, x over x square plus 1 dx by variable separable method. Okay, there must be an integration constant. When you differentiate cosine, you get minus sign, but minus sign is missing there, so you can use a minus and minus, and therefore the left hand side it will be minus ln cosine y, which is equal to the right hand side it will be 2x. It should have been 2x here, so you can multiply and divide by 2, therefore 1 over 2 will be there. Then this part will be ln x by x square plus 1 plus c. For your information, integral f of x in the denominator, f prime in the numerator dx will be always leading to ln of the denominator f of x. Okay, this is the technique I used here, or we can use u substitution method, and this is ln cosine y. It will be ln cosine y power minus 1. The right answer it will be 1 over 2 ln x square plus 1. Plus you can take this one ln c, all the terms involve ln, so we can take the constant term also involves ln. ln c is at another constant, so nothing to worry, at another constant. So we can write here, we can write after integration, we can write ln c plus ln c. Now we can remove ln on both sides by choosing exponential, isn't it? It will be e power ln. So the left hand side it will be cosine inverse. It will be 1 over cosine, 1 over cosine. The right hand side will be e to the power ln into x square plus 1, this half to the power of this term, plus, and you know the ln c will be in the power, so you can write by power rule e power ln c. And what happens to the left hand side when you write 1 over cosine y, this is secant y, in the right hand side it will be x square plus 1 to the power half into c. So y, when you take secant inverse on both sides, y will be secant inverse of c times square root of x square plus 1. That will be the end of problem number 16. Now I am moving to problem number 18. Problem number 18. Now again the same technique, separation of all variables. Y in the left side, right side will be x. This is x square dy over dx. In the right hand side is 1 minus x square. From the last two terms, pick y square as common factor, then it will be again 1 minus x square. Now there is 1 minus x square, 1 minus x square a common factor, you will get 1 minus x square common factor, and here the remaining will be 1 plus the other part will give you y square. So this is x square dy over dx, the left side. Now again separate x and y. This will be dy over 1 plus y square on the left side, 1 minus x square times dx divided by x square on the right side. That will lead to integration. We are going to integrate it. Before integration, we can write this one, integral dy over 1 plus y square, which is tan inverse, of course. The right hand side it will be 1 over x square minus, so separate this one, 1 over x square minus x square over x square, which will be minus 1, and integration dx. So when you integrate on both sides, left hand side is obviously it's the formula of tan inverse y. Right hand side 1 over x square, when you integrate, use this formula x power n dx, which is x power n plus 1 over n plus 1. So here the power n is minus 2. You will get minus 2 over x power 3 and minus 1 will give you x plus an integration constant is c. Well, when you want to remove tan inverse, take tan on both sides. That is y is equal to tan of minus 2 over x power 3 minus x plus c. That's the end of question number 18. Now let's go to next question, which is find explicit particular solutions of the initial value problem and problems 19 to 28. So you got to solve all the, you got to practice all the problems from 19 to 28. In this syllabus, we will solve question number 18 alone. Again, try to separate and use the same technique, but at the end, you got to find the value of the constant. So you will get a particular solution. Initially, in the previous cases, all we found were general solutions. There is no specific value for C. But in this problem, as the initial condition has been given, we will find the value of the constant. So let's try to separate this one. Dy over dx is equal to 6 into e raised to 2x e raised to minus s by using the power of exponents. Now all y in one direction, so what we can do is multiply e power y on both the sides. This will be e power y dy 6 into e raised to 2x dx. What's next is integration. Integration of e power, this, remember this formula, integral e power mx dx is e power mx over m plus c, right? So here the coefficient of the variable is 1, so the left hand side is just e raised to y, the right hand side is 6 times e raised to 2x over 3 plus c, and you will end up with writing e raised to y is equal to 3 e raised to 2x plus c. Call it this as equation number 1. After finding c, then we will find, use initial condition, x is 0 gives y is 0 in equation number 1. So in this equation, put x is 0, y is 0. Y is 0 gives left hand side is 1. The right hand side is 3 times e power 0 again. So left hand side e power 0, right hand side e power 3 into e power 0 plus c. So 1 is equal to 3 plus c gives c is 1 minus 3. 1 minus 3. C is minus 2. Now use c is minus 2 in c is minus 2, 1 minus 3 is minus 2 in equation number 1. So what you get is e raised to y is equal to 3 into e raised to 2x minus 2. So we want to remove the exponential in the left hand side, take ln on both the sides. Therefore it will be y in the left hand side ln 3 e raised to 2x minus 2 is the particular solution of this problem. Okay, that's end of question number 27. Now we will go to the next problem. Now it will be applications of this type of population growth. A certain city had a population of 25,000 in 1960. So you must have a concept of a real line to understand. This is a timeline. Make 1960 as your time, 0 starting time. The population at this time is 25,000. The next is 1970, which is T is 10 years from 1960. The population is 30,000. Assuming that the population will continue to grow exponentially at a constant rate, what population can its city planners expect in the year 20,000? That's the question. So the year here is 20,000 exactly. When t is 0, it is 1960. Then exactly after t is 40 years. After 40 years, what is the expected population here? Now we should recall the differential equation that is representing the population growth. When it's population p, this is modeled by the differential equation dp over dt, which is equal to k times p. P is a function of t. You can write p of t as well. Okay, and its solution is given by p of t is equal to it's a growth. So you will write a population, a constant p0 here, which is initial population, e raised to minus or plus kt. This is not minus k, this is plus k. If it is decay, then it will be minus k, okay, plus kt. So this is the equation we are going to use to solve this population growth problem. Call it equation number 1. Well, you know what is P0 here. P0 is initial population. P0. So P0 is 25,000 when T is 0. When T is 0. When T is 10, use T is 10 in equation number 1. So this is our equation number 1. We know when T is 10, the population is 30,000 given in the problem. So 30,000 is the population. 30,000 the population. When T is 10, we'll put T is 10, P value is 30,000, P0 is given 25,000. All information is given here. P value is 30,000, P0 is 25,000, K value is unknown. That is what we are going to find by using, by using the information P0 and second P value when T is 10, we are going to find the value of K and then use the value of K to find the final one, population or time, whatever we want. So this is e raised to K times T. T is 10 and divide by 25,000 on both sides. 25,000 on both sides, you will get 30 over 25, which is 6 over 5. The left hand side, e raised to 10k. And if you want to remove exponential, take ln on both sides. It will be ln 6 over 5 is equal to 10k. So k is ln 6 over 5 divided by 10. Use your calculator to find this k value, which will be 0.01823. 1823. So we found k value 0.1823. Next, the final stage, finding the population P when T is 40. T is 40 in equation 1 gives P. P is unknown, so we are going to find P of T or P. P0 is 25,000 as usual. E raised to K. K is 0.01823 and T value is 40. Just type this one in your calculator. You are allowed to use calculator. So the answer will be 51,840. This is the population after 40 years. That's by 2000. The city expects the population 51,840. That's the end of the problem 33. Now let's move to the next problem 35. Radiocarbon dating. The carbon extracted from an ancient skull contained only 1/6 as much as 14C as carbon extracted from the present day bone. How old is the skull? So you are dating back to the origin when the skull was actually the death of the person. How old is the skull? That's the question here. Well, the differential equation modeled here is dn over dt, which is decay actually, isn't it? We are dating back to the previous. So this minus k times t, which will give the solution. N is n0 into e power minus kt. And what is n here? What is n here? N is atoms of a certain radioactive material, radioactive isotope at time t. Okay, and n0 here, n0 is the present day bone. The number of carbon isotopes are extracted from the present day bone. So n0 is 14C carbon from present day bone. What is given is n is after time t, n is what is available in this problem. N is 1 over 1/6 is given 1/6 of 10, 1/6 of n0. This is what we are going to use in equation number 1. Okay. What's the question? How old is, what is time? When n is given, what is time? So question is what is time? Then equation number 1 gives n. In the left hand side it is 1 over 6 n0. In the right hand side it is n0 e raised to minus kt. And you know, refer the example 4 on the textbook. It's given what is k. K for this kind of radioactive radiocarbon dating. K value has been given as 0.000216. Just we have to use it for all radiocarbon dating problems. Therefore, on the right hand side, both divided by n0, and you will end up with 1 over 6 e raised to minus 0.000216 t, and remove exponential on both sides. It will be ln 1 over 6 minus 0.000216 t. So what is t? T is ln 1 over 6 over minus 0.000216. It will be equal to approximately 14,703 years. So the skull is around 14,735 years old. That is the answer of question number 35. This problem number 44. When sugar is dissolved in water, the amount A that remains undissolved after t minutes satisfies the differential equation. So differential equation is given, which is dA over dt, which is negative Ka. So as per the pattern of this kind of first order differential equation, the answer solution of this one must be A. A is a function of t. A is equal to A0 e raised to minus kt. This must be the solution pattern. So we can directly call it equation number 1. And whereas A0 is the initial amount of sugar and remains undissolved after at T0, isn't it? So A0 here, right? A is sugar remains undissolved, not dissolved. So how much remains undissolved? That is A. So write down A, sugar amount remains undissolved at time t. So A0 is initial when time is 0. When you start, there will be whole sugar and remains undissolved, isn't it? That's right. So if 25% of sugar dissolves after 1 minute, so some clue has been given. Whatever at about the A0, we don't know what is A0, but after 1 minute, when t is 1, then A is 25% sugar dissolves, so 75 remains undissolved. Therefore, this is 0.75 times A0. A0 is initial sugar. Out of the initial sugar, 75% remains undissolved. Okay. So A, when t is 1, A is this one. So these two values can be used in equation number 1 to figure out what is K. So equation number 1 gives left hand side is 0.75. A0 is equal to A0 e raised to minus K t. Okay, t value is 1 in this particular case. So A0 can be divided on both sides. On the left hand side is 0.75, which is equal to e raised to minus k. So take ln on both sides. This ln 0.75 is equal to minus k, and k is equal to minus ln 0.75. Okay, this is a calculator. It will be 0.28768. So we got the value of k. And next question, what's remaining? How long does it take for half of the sugar to dissolve? So when we want the time, so that A is half dissolved, so half remains undissolved, half 50%, 0.5 times A0. So A value is given, then what is the time t? So equation number 1, again we should recall equation number 1. A value is 0.5 times A0. On the right hand side, A0 e raised to minus k value is 0.28768 times t. We need to find t. Can divide A0 on both sides and take ln. It will be ln 0.5. So A0 cancel both sides. Ln will remove the exponential. It will be minus 0.28768 times t. So t is ln 0.5 over negative 0.28768, which is approximately 2.41 minutes. So if you want to get half the sugar dissolved or remains undissolved, the time it takes is 2.41 minutes. That's the end of the problem number 44. Now let us see 49. Okay, the same type of problem in Newton's law of cooling. 49. Well, a cake is removed from an oven to 10 degree F and left to cool at room temperature which is 70 degree Fahrenheit. After 30 minutes, the temperature of that cake is 140 degree F. Then when will it be 100 F? So the question is in the cooling, Newton's law of cooling, and the differential equation modeling the Newton's law of cooling will be dt, rate of dt, that is rate of change of the temperature of the body, is directly proportional to this is cooling, so minus k times the difference between the body temperature and the surrounding. It means the atmosphere temperature. We call it T minus A. If you flip that A minus T, this k can be positive. Okay, this is our differential equation. So solution will be this T minus A is equal to T0 minus A e power minus kt, and we want the T. A is fixed. T is the temperature of the body at time t. A is the room temperature or atmosphere temperature, we can call it temperature of the medium. A, room temperature we can call temperature of the body T. So if you want, you can write here T, temperature of the body. A is medium, temperature of the medium, right? And then you can rewrite this rule. This result T is minus A will be positive A, the right side positive A, plus T0 minus A. T0 is the initial temperature of the body, e power minus kt. This is the formula we are going to use which is Newton's law of cooling. Call it equation number 1. Well, initially when you draw the real line again, real number time line, when t is 0, the body, when the cake is removed from the oven, your time clock starts and the temperature is capital T0, which is 21 degree Fahrenheit. After 30 minutes, so when t is 30, the temperature of the cake is 140 degree F. This is another T. So we can use these two information to figure out the value of K. And the question is, when will it be? So the next temperature is given 100 F Fahrenheit. Then what is T? That's the question. Use the first two information to find K value and use K and this temperature of the body T in this equation number 1 to find out the T value, small t, time. At what time it will be 100 Fahrenheit, right? Let's start in equation number 1. T is 30 and capital T is 140, and there is one more information given, 70 degree, which is room temperature, isn't it? So A value is 70 degree Fahrenheit. This information in, and A is 70 degree F in equation number 1. What we get is, the left hand side is 140, the right hand side A is 70 plus T0 minus A, you can fix it, T0 minus A, both are constants. In this particular problem, this 1 can be rewritten as T is equal to 70. 70 plus T0 is 210, that is initial temperature 210 is here. 210 minus 70, which is 140 e power minus kT. So this equation number 1 simplified for this particular problem, call it equation number 2. Now let us use equation number 2. 70 plus 140 e raised to minus kT from equation number 2, what we are getting. So 70 is subtracted on the left hand side, it is 70 and 1 is equal to 140 e power minus kT. Divide by 140 on both sides, it will be 1 by 2, left hand side, e power minus kT. And T value, what is this T value here? T value is 30. So this T value I should use 30 here, e raised to minus k times 30. Now take ln half is equal to minus k times 30. So what is k? K is ln 0.5 whole divided by negative 30. What we get is 0.023105. This is our k value. Next, after finding k value, use equation number 2 to find the final t value. When will it be 100 F? If T, capital T, temperature of the body is 100 F, then what is small t? What is the time? So capital T is 100 in equation number 2, gives 100 is equal to, in the same formula, this is 70 plus 140 e raised to minus k. K is e raised to minus k. Which is 0.023105 times t. So we got to find t. Simplify this one. 100 minus 70 is 30. 30 divided by 140, you will get 30 divided by 140, which is e power 0.023105 times t. Take ln on both sides. ln 3 over 14 minus 0.023105 t. So t is, when you divide this term here in the left hand side, you will get which is approximately 66 point. So t is 66.67 minutes. That's it. That's the end of this problem. You can check answer. Problem number 49 is over. Let's move to problem number 50. So we are here to solve problem number 50. Look at this problem number 50. Amount of the amount A of T. So this is pollution increasing. When it is increasing, it is a population growth type, isn't it? So we will write a differential equation for this one. The amount A of T of atmosphere pollutants in a certain mountain valley grows naturally and is tripling every 7.5 years. Okay, initially we don't know what is amount. Okay, let's take it initial amount of pollution. A of T is atmospheric pollutant density at time t. That is it. So differential equation will be d of A, dA with respect to t is, this is increasing, so positive k times A or A of t, and the solution will be A of t is equal to A0 e raised to k small t. This is what we are going to use question number 1. And look at this question. So we don't know what is initial. We will see some information given. If initially when t is 0 we call it A0, then when t is 7.5 it will be 3 times A0. If amount of pollutant is A0, then it will be 3 times A0 because it is given here. A certain mountain valley grows naturally and tripling every 7.5 years. If time 0 is A0, then time 7.5 years will give you 3 times A0. Let's see. Now question A, we are going to answer question number A. If the initial amount is, so A0 is 10 pu. Write the formula for A of t giving amount pu in present t years. So this is equation number 1. Equation number 1 will give you A of t. A0 initial amount is 10 pollutant units e raised to kt. This is what they want. This is what the answer for equation number 1. Call it answer for A. Then what will be the amount in pu of pollutants present in the valley atmosphere after 5 years? So to find after 5 years, when you got to put t is equal to 5 in this equation number 2, but you must know what is k. We got to find k value by using this information. When t is 7.5, what is A? So this is 3 times A0 is equal to A0 into e power k. T is 7.5. Divide by A0 on both sides, it's 3. The left hand side e raised to 7.5k. And if you want to take remove exponential, you take ln 3 is equal to 7.5k. That will give k is ln 3 over 7.5. The k value will be 0.1465. Now let us use that information here, k value, to find b. What will be the amount when t is 5? Question D. When T is 5, the formula for A will be A0. A0 is 10. Initially, it is 10 pollutant units. E power k. K is 0.1465 and T is 5. Just type in your calculator. It will give you an answer. Just type this one in your calculator when T is 5. It is approximately 20.80 pollutant units PU. This is the answer for part B. For part C, if it will be dangerous to stay in the valley when the amount of pollutant reaches. So amount of pollutant A is given. Question is how long will this take? You got A. A is 100 in equation number 2. Number 2 is here. Then question is what is T? Okay. So in equation number 2, left hand side is 100 and the right hand side is 10 times e power k. K is 0.1465 and T is that thing to be found. Now simplify this one. Divide by 10, left hand side will be 10, which is e power 0.1465 times t in the right hand side. Take ln on both sides. It will be ln 10 0.1465 t. So the t value can be found by dividing ln 10 divided by 0.1465, which is 15.72 years. So if the pollutant level should reach 100 pollutant units, it will take, so pollutant units are increasing this problem, so it will take 15.72 years. That's the end of this problem. The entire solution is in this page. Okay. Next question is radioactive decay. Problem number 51 from the PowerPoint. Radioactive decay. So it is decreasing, that K will be negative, and we will write the differential. An accident at a nuclear power plant has left the surrounding area polluted with radioactive material that decays naturally, so decreasing. The initial amount of radioactive material present is 15. So when T is 0, we can call radioactive material A. The amount of radioactive material is A0, which is 15 SU, safe units. And when T is 5, it is A, which is 10 SU. It is decreasing. So we will write the formula as rate of change of the radioactive material with respect to T is negative K times A. It's decreasing. So its solution A must be A0 into e raised to minus K times T. This is our equation number 1, which is going to be used to solve this problem. Okay. And initial condition, these two information can be used to find K value, and then use the K value to find out other problems. Write the formula. Question number 1 is write the formula. Write the formula for A of T, which is here. This is answer for A. Now B, to find B, we need the K value. So use the initial information T0, A0 here, A value when T is 5, using A is 10 and T is 5 in equation 1. What we get is 10 in the left hand side. A0 is what? In the initial stage, A0 was 15 and it is reducing. 15 e raised to minus K and 5 is T. Now the same way we are going to simplify, divide by 15 on both sides, it will be 2 over 3 in the left hand side, e power minus 5k, and take ln on both sides. Ln 2 over 3 is equal to minus 5k, so that will give you k is ln 2 over 3 divided by minus 5 is equal to 0.0811 approximately. K value is given. Now to find B, what amount of radioactive materials A you have to find after 8 months. So all in months, all the units are in months, so nothing to change in T. If T is 8, what is A? State in equation number 1. And B becomes B the answer from 1, equation number 1 gives A is equal to, the initial amount A is 15 e power minus k minus 0.0811, and the time T is 8 months here in B. So just type this one in your calculator, straight away you'll get 7.84 safe units in case number B. So case number C is very similar to the one. Your amount A is given, find T value. So I can write it here again in question number C. Question number C. If A amount is given, then what is T? That's the question. Then equation number 1 gives 1 in the left hand side. A0 is 15 units, e power minus 0.0811 T. We want to find T value. So divide by 15, it will be 1 over 15 in the left hand side, e raised to minus 0.0811 T. Take a ln on both sides. Ln 1 over 15, which is equal to negative 0.0811 T. So T is nothing but T is ln 1 over 15 divided by negative 0.0811. Will approximately get you 33.3915 months. That is, T will be approximately 33.4 months in question number C. That's the end. That's the end. I'll show you the entire problem in one shot. Okay, that's the end of this problem.